in any programming language, we see kind of how much it provides explicit and how much it provides implicit, means how much it does the work behind the scene and how much work it does means in front, means there is nothing hidden. So like we discussed that in Python, Python is generally preferred because most of the thing is data structure based and it's explicit, means we just need to kind of get the handle or reference to the data structure, module, function, class, whatsoever, and then we can manipulate over it. Means it's a completely explicit. There is a very few things that are hidden, like we talked about methods, how we create the method object from the user-defined function. Okay, so now the story of implicit and explicit in the programming language, that we saw that we need explicit. Means if implicit is required when language takes the control, okay, and explicit is required when programmer takes the control. So if programmer is powerful, then certainly language has to provide a mean to kind of to get something done or most of the thing done explicitly. So if we see now the 3D graphics through Opengl, earlier things were implicit, means it maintains states and then it provides a lot of APIs, and if someone calls, then everything happens behind the scene, okay, not outside the scene. So that is kind of traditional way of doing the Opengl programming. Okay, it is also called a fixed function pipeline. Now, when kind of after the introduction of shaders language, like a geometry shader and a fragment shader, or we can say pixel-wise shader. So each pixel color, we said we don't call it pixel shader because whatever color we set for each pixel, it is not guaranteed that pixel will go into the color buffer. Means that pixel will get kind of kicked out because of depth test or stencil test and so many tests. Okay. So, but still, if we see kind of shaders, then in geometry shader also, in fragment shader also, means we have kind of a full control, especially in the light calculation. When we go for a lighting calculation in Opengl, then all the vector calculation and the light calculation, everything a programmer can. Means if programmer is expert, if programmer knows kind of mathematics very well, then he can do a good amount of thing in kind of fragment shader, not require the kind of the implicit way of programming. Like lighting model, we have to specify lighting model. Now, a specular color, the shining of the specular in the lighting, it will happen after the texture comes into the picture. It is one-sided, two-sided. Then the calculation of the lighting will be near, where it is local or remote. Means so many things. Means it's a kind of mesh of states. Then how many light model we can specify, maximum 16 or 8. Then each light model we have to specify kind of material property. Then internally it will do a multiplication with the material property and the light property. If multiple light sources are there, then each calculation there it would too much, means that much implicit is too much. So Opengl kind of it came forward and it brought kind of a shader. So shaders language anyway, it is useful when it comes to kind of a GPU kind of calculation, where the mathematical calculation goes to a graphical. But apart from still, the calculation is in the hand of programmer. So programmer in the kind of a fragment shader, it can do all the kind of calculation. It's in hand of programmer. So it's like a Python kind of a calculation where things are becoming explicit because of the shader programming. Okay, but still the way we reiterated that still in Python there are few things that are still hidden, like from the user-defined function to a method conversion. Still in Opengl also few things are hidden. Okay, like in the lighting, the things that is hidden is backside lighting. means I have a kind of sphere, like I have a sphere, then this is outside and this is inside. Okay, then how we do the calculation of inside and how we do the calculation of outside. So generally we go for kind of normal. So what is the normal of the each surface? Means there is nothing like a surface, means whatever the normal comes into the picture and the light vector. Okay, then how we manipulate, and that the way we think about the surface curl. Okay, so that happens, means everything is there, nothing front or back, depending upon the kind of normal vector and the light vector. We think about the color of a surface. Okay, so in OpenGL, still the way we talk explicit and implicit. So if we consider the shaders programming language explicit language where we do all the mathematical computation, but still few things are still hidden in OpenGL when we go for the surfaces drawing. So typically in lighting calculation, we see kind of, I won't say glitches, but a weird kind of behavior where we go for lighting calculation of the front face and back face. Okay, so sometimes we kind of like moon kind of simulation where if light is not falling directly on the surface, means the surface that is getting hidden, I won't say it is a back surface, like if it is a sphere, lighting is coming from here, then back side will not get illuminated, even though it is in a depth test, it will come in a front, but still it will come in a kind of ambient calculation. So if we do kind of these kind of calculation, but still sometimes like if we go for transparency and those kind of calculation, it is showing some kind of weird behavior. Means I would say it's not something that would be expected. Okay, so now we'll see kind of how whatever is implicit in the OpenGL, that are state management and the shader. So how kind of their relationship, or it's a kind of the synergy between them, how it happens. Now if we see about kind of discrepancy, so discrepancy when it comes to the lighting calculation in the front surface and back surface calculation, which leads to a kind of a weird problem that we'll see how we can get rid of it. So typically like we can use cull face. So we can cull, we can cut a particular face, front face or back face of a kind of a particular surface, and then we can get rid of many kind of weird behavior that we'll see. But in addition to that, we see that how we can make synergy between the OpenGL shaders code and OpenGL Python code or C code or C++ code outside, so that whatever we draw in the shaders code, how it goes finally in the kind of the backend source, and they do the manipulation. So we will focus on kind of the discrepancy, what we see in the face, back face and front face drawing when we do the lighting calculation, and then we get a kind of a remedy of it through the cull surface, and how we do the synergy of the cull surface or any kind of state management in OpenGL that will do the kind of the harmony relationship between the shader code and the backend, the Python code. So that will. Okay, so we will proceed on cull face. So what is kind of why we need kind of culling a face? Okay, so this is Linux Mint. Okay, reversing and culling polygon faces. So polygon, I believe it's quite easy to understand. So basic thing that we draw, it's called primitive, and in OpenGL, like triangle, quad. So these are polygons. Okay, so we'll see what is polygon faces, front and back, and then what is culling polygon faces and reversing the polygon faces clockwise and counterclockwise. Okay, so before we proceed, little bit we'll talk about the OpenGL pipelining. So this is a surface. It has three vertices V1, V2 and V3. So there are three vertices, and if there are three vertices, then certainly there is a surface. So surface is visible. We can see there is a triangular surface that is built because of three vertices. Now we have vertex shader and fragment shader. So three vertices are fed into vertex shader. So vertex shader get executed per vertex. So for each vertex, vertex shader is executed. And when a primitive is completed, so this is here, the primitive is a kind of GL triangles. Okay, so we can think it as a primitive is GL triangle. Okay, so primitive is GL triangles. Okay, so name of the primitive is GL triangles. So this is primitive name. Okay, so this is GL triangle and it has three vertices. All three vertices are fed into vertex shader, each vertex one time till it completes the primitive. So one primitive is completed, transformed surface interpolated. So transformed now because of the vertex shader where we apply different matrices like model view and projection matrices, and then we transform the vertices. One vertices get transformed, then the surface what we see, the surface has a set of pixels. So when we have three vertices, when it get transformed based upon the primitive, we come to a surface that is transformed surface. If it is a surface, then there are set of pixels. Now this set of pixels, so those pixels interpolated pixels, mean in the sense that a kind of the new position of the pixel and then a new normal. So normal also get transformed. So the whatever the interpolation happens for the pixel positions, so those transformed surface interpolated pixel, they are fed into fragment shader, and fragment shader generates colored pixel. So pixels are getting colored. Now the colored pixel, it is called colored pixel, or we can kind of call colored fragments. So when pixel is not a part of frame buffer, color frame buffer, till then it is a fragment. So this is the name kind of suggested. So okay, so if this is a pix, okay, so rather we can say kind of we can say like it's a fragment. Okay, so pixel of fragment, and it is a fragment because it is okay, colored pixel of fragment. Then it passes through various tests like face cull test and depth test, stencil test, and so many, and it becomes candidate of the frame before it passes the test. So if it passes the test, then the fragment actually it becomes pixel. So it became color frame buffer pixel. Otherwise, before that it is not a pixel, it is a fragment. I mean, these are the terminology that is in fashion. Okay, so now we understood that if we kind of combine the vertices, then it forms a surface, and then surface, since vertex get transformed, so surface get transformed, and then whatever the new interpolated pixel locations, and I mean I can specify texel also, and the new interpolated normal that is spread into fragment shader, it becomes colored pixel or fragment. It passes varial test, and if it passes through, that becomes pixel, otherwise it is called fragment, and it becomes member of the color framework. So this is the Opengl pipelining. Opengl pipelining is big thing, and there are many things may happen in texture wise also, like creation of the texture object and texture unit and so many things. So this is part of it, and the biggest part is, so before it is fed, so this is CPU code. So like here we can say C or Python code, and then it is fed into vertex. So this is shader programming, that is C code, and once it comes out the colored pixel, then it becomes part of the C or Python code, and it becomes C and Python code. So output, this area is Python code, and this area is shader code, and this area is Python code again. So input before it is fed into the shader, and then output whatever we receive. Then so it depends upon how we have set up the test environment through which it would pass. Okay, now polygon face we have seen. So if there are 3 vertices, there can be 4 vertices, 5 vertices, depend upon what kind of primitive I have taken. So right now we have taken GL triangles primitive. So if GL triangle primitive is there, then if there are 3 vertices, then we have front face, that anyway we are seeing, and there is a back face that we can imagine. So if there is a surface, then there has to be 2 faces. One is front face and one is back face. Like we have a kind of model. So if I have a model is built because we have so many triangles. We can see there are so many triangles. So triangles are kind of, they are aggregated, and it forms a shape model. Now each triangle has front face and back face. So altogether we can say that this model has front and back face. So this is front, the outside of the glass or cup, and inside it is what we see kind of more clearly. So this is the back face, that is inside it, and whatever we see that is outside, that is the front face. Okay, so front face of the glass, and inside what we see the surfaces. So that is back face. So okay, so inside the curve, I mean if I have a surface, then front face and back face, like that. If there is a surface, because of the triangles are combined together, then back side of the triangle is also there. Okay, so polygon faces. Okay, so what is polygon face? So we saw it is a polygon is generally generated by the set of vertices, and it has two faces since it is a two-dimensional item. So any two-dimensional item has two faces, front and back. Okay, so how we decide that something is kind of a front face and something is back face? So when we declare like GL triangle primitive, when we say mine is a GL triangle primitive, and we put a vertices, like if I am saying that my vertices is V1, V2, V3, so it difference means I can specify vertices in clock direction, I can specify vertices in, so if I declare that my polygon is GL triangles, then I have to specify the vertices also. So if I specify vertices in counterclockwise, then whatever the face is generated, that is considered as front face. And whatever the face is generated because of the clockwise, so if I am thinking this V1, V2, V3, so V1, V2, V3, if we specify, then it is a counterclockwise the way we are specifying the vertices. If we are specifying the vertices in counterclockwise, the face what we are seeing, so that face is kind of front face. Okay, so if it is a counterclockwise, then the back side is automatically it is clockwise. So back face that is clockwise is the face which is clockwise, that is the back side, so that is called back face. The face which is counterclockwise, so that is called front face. So this is the way. So I have only three vertices, but depending upon the vertex, so like generally we draw the item like this. Okay, like the actual OpenGL drawing. For that we write the code like this. GL begin, and then we specify what is the a primitive name. So that is the kind of grammar, and then we specify GL vertex, GL color, and kind of GL normal vector. Okay, I think text coordinate. So these are the stuff generally we specify, and so if I specify the vertex like here in this example, like V2, V3 and V1. So if I specify vertex like this, then it is considered as clockwise, and whatever the surface we are seeing resultant, so that surface is considered as the normal, as considered as the front face. Okay, if it is front face, then if we specify normal, so we can specify normal, then it is front face normal. Okay, so this is the science. So when we draw vertices in counterclockwise, then that is front face. Then by default, then other face would become the back face. Okay, so we are covering kind of what is polygon face. We will move to culling polygon face. Okay, what is culling polygon face? Culling means cutting, removing. So, like we have a kind of a sphere, and a sphere is made up of set of triangles, GL triangle surfaces. So, whatever we are seeing, this is front face. Okay, if I rotate this sphere or football, then again it is front face. Inside it, okay, so if I cut it, okay, so if I cut it, then inside it there is a back face, the way we shown. Okay, so inside, if we cut it, then inside, so this is back face, and if we cut it, then inside it is like a back face. Okay, so outside what we see is the front face. If we cut, then the inside cut, not the, if I rotate, all the outside around 360 degree is front face, and if we cut, then inside what the surface we see, we will see that is the back face. Means if this is a triangle, then other side of the triangle is the back face. So other side of the triangle is not the other side of the sphere. That is the inside of the sphere. Okay, so if it is made of kind of a cloth or leather, then the other side of the leather. Okay, so if my football, if I am kind of playing football, then certainly I am not going to show the inside surface, but Opengl takes care of the drawing the inside surface also. So unnecessary computation we would kind of handle. So in that way we can remove the mathematical computation for a particular surface. So that is the part of the discussion. So I can say enable cull face, and then I can say cull face back, because we don't need back. Okay, so only we need to draw the front face, the inside of the this football or inside of this sphere. So that we don't want to draw. If we don't want to draw, explicitly I can say that just cull the back side. I don't want the back side. Okay, so cull can be back, front and back means I don't want anything. So that is front and back. Otherwise, whatever we need, we are only drawing the back side. So in that sense, we will cull front. For that, we need to enable first GL cull face. This is kind of a state management in Opengl, and we need to enable and disable a particular feature. So we need to enable cull face first, and then we have to specify which face we want to cull. And back face means the surface that is generated when vertices are in clockwise. If it is counterclockwise, then that is front. So if I specify back, then front it would not draw, only back side it would draw. So it would save 50% of it would double the speed. Or if we draw front, then it would draw the front, and back it wouldn't draw. Okay, if I cull face front and back, then nothing would be drawn. Okay, so we are now in the topic reverse polygon face. So we can change the grammar, internal grammar of the Opengl. So Opengl internal grammar is counterclockwise is the front face and clockwise is the back face. I can say GL front face is clockwise. So we reverse it. If we reverse it, then whatever we are seeing as front face becomes back and back face becomes front. Okay, so the glass front face becomes back, and if we cut the glass, we see the inside. So that inside becomes front. If we set the orientation of the front face, the grammar of the front face as clockwise. Otherwise, by default, if front face is set for the counterclockwise vertices. So that is the science. So we saw two kind of API. One is culling the polygon face. So it consider the front face as counterclockwise or whatever is set through GL front face, and then whatever we specify back, front, so that surface it would cull. Okay, so that is the scenario. Now in lab session, we will really see what is front and back. So I have a kind of a GL triangle and I have two light sources. One light source is red and one light source is blue. Okay, whereas the surface color is white. So when white diffuse light falls on the surface, it illuminates it as red. Okay, now so now we can, I think we'll proceed. Okay, so since two lights are different, then coloring is different of the both faces. Means OpenGL after the shaders pipelining, once shader drawing is over, then OpenGL identifies the surface as front or back. Even though the pixel would be same, but it identifies front and back. So the side which is facing the light 1 is red, and side that is facing the lights 2, the back side, is blue. So same triangle, we have red and blue. Okay, so I need to enable the cull facing, and if I say please remove the back side, then this, so only red is visible and back side there is nothing. It is no color. We can say it is a black. And if we cull front side, then only blue color would appear and red color would not appear. How it works. So we will show how it works. Then we will proceed with kind of writing the actual code. So if this is a counterclockwise, then certainly there is a normal. If it is counterclockwise, then certainly there is a normal. First I would reflect it here. Then certainly there is a normal. Suppose I have a normal. So there are 3 vertices. And vertices are shown in V2, V3, V1. So it is counterclockwise. And then we have a normal. Now I am rotating this vertex along x-axis. So this is x-axis. So this is x-axis is in red. This is what I believe. So so if I rotate along x-axis, then slowly this surface would get rotated, and so one time the surface would be something like this. So once it starts rotating, then one moment it would become like this. It will be very thin. Since it is rotating along x-axis, then it will be little bigger. Then slowly it would become smaller, and we can see only one line. okay, then it would kind of go in other direction. So, okay, so normal. So when we are rotating, so normal is facing red light. So from this stage to this stage, this stage, this stage. Now normal is, okay, so we are rotating. So here, okay, so normal is also getting rotated. Okay, so at this stage, normal is pointing exactly down. Okay, and then normal starts pointing towards blue light if I keep on rotating. Okay, so now the calculation generally happens in shader is the normal what we see and the light falls, the direction of the light. Okay, they must not, now it is kind of 0 degree. So it must not cross 90 degree. So up to 90 degree it would do the diffuse color. Beyond that it won't do. So if I am rotating it, one time it becomes 90 degree and there is no coloring. Anyway we cannot see the surface. And after that normal start pointing into blue light. The way we started red light and blue light. So if we are rotating, then after certain rotation 90 degree, then it starts pointing. It starts pointing towards blue light. So blue light is getting the normal. So if it is pointing towards blue light, then the pixel color would be blue. So we are seeing two pixel color. So when the surface is normal is facing the red light, then we are seeing the red light when we are rotating it, and when normal starts facing the blue light, then we are seeing the color blue. I mean we can see. So we'll see the example. And if that is the scenario, then so this scenario we have not enabled the cull facing. So if I have enabled cull facing back, then if I enable cull facing back, then normal when it is facing red light, so that area is considered as front face because that is counterclockwise. So only red would appear when it goes towards blue light. Okay, then it would illuminate as blue. Okay, but since Opengl identifies front face and back face, so when it is blue color is illuminated when it is going other side. So whatever the blue color it is facing towards the user, so that is the back side, so it won't show. So only red color it would show if I do the cull facing. On the other hand, if I do the cull facing front, okay, then red light would illuminate the front face as red, but we don't want the front face, so there would be nothing. So the front side, even though it is illuminated with red, it would not draw. So once it passes the shader's code, so it does the coloring of the pixel or fragment, but cull test it would not pass because front side we don't want. The face that is counterclockwise, that we don't want. So in that scenario, it would not go to the color buffer. So we would not see. So there are two parts. So in the first part, we see only the red color and we keep rotating. There is no color. But in second part, when we say cull face front, then front side, so this side would not appear at all. And only back side would appear. When normal goes that side, it rotates. And that we see blue because back side is enabled. Okay, so this is what the example will show. Whatever behavior we are seeing, that behavior we can just turn upside down if I set GL front face as clockwise. In that way, if I cull the back face, okay, even though it is in front of red light, okay, so we will see only the blue. Okay, so and if I do cull facing of the front, then even if we are the front of blue light, we'll see the red. Okay, I mean it looks a little kind of clumsy. Okay, convoluted. Okay, we'll see in the example. Okay, so what we did, we turn around the vertices. So now if vertex is clockwise, that is considered as front. If clockwise is considered front, whatever we see at the back side, that became the front. So if I say cull back, okay, whatever earlier it was front, that is gone, and whatever the back, okay, so that became front. So if I say cull face back, the front side is gone, means earlier whatever the front side is gone, so only back side, earlier back side will be shown. So this is how it would be. So probably we'll see in the example, and then it would be kind of more clear. We can start. Okay, so we already have a few files, one by one probably we'll see, and I have a skeleton code. So this is Opengl skeleton code for the glut. I believe it is famous, so everyone would be knowing. So we import from glut gl, and we have init display reshape and then other initialization function. So this is ready made. So we would fill in. So probably I can show the shader code that we are using. Okay, so this is very shortcut shader code. So this small is vertex shader, and then we have fragment shader. So in the fragment shader we have the structure for the material and for the light. Okay, and then we kind of iterate for each light, and then we do the computation. So if it is texture, if the VAO is for the texture, I mean we are specifying coordinate for the texture, then it does computation for the texture, otherwise it is for the light. And then we finally compute if kind of if we don't want lighting calculation in certain case, then we go straight forward. So that's it. So whatever the kind of we are applying the graphics, so it is this big shader only. Okay, so we will fill in. So that is the idea. Okay, so we will import now whatever we showed. So I would say import sys.path append os.path expand user. Okay, so this is how we add whatever we showed now, and then we can say like from mix extra shader. So this is the module that I showed. So from there we'll import the shader class. Okay, so shader has util shader.util_i. So util I is a okay, so it's a kind of I believe I can show it. So shader class we are talking here, and then we have util I, that is a kind of ready-made instantiation from the one util C object, that is class. So that is Python is like we can so this is a object, so that we can also refer. Okay, then now we will have a kind of a shader I equal to none. Now we'll go to init and I'll say global shader I. So whatever shader I am showing, okay, so we'll instantiate the shader slowly. If we kind of watch the tutorial, then you can, it's not very difficult. So we instantiate the shader I. Shader I is shader and obj file equal to none. Okay, so all these are local code. So we are not using any open source, any kind of tool. Okay, now, so we have a global shader where obj file, a Blender obj file is nothing. And now it will contain other shaders. So shader I dot children dot append shader obj file equal to none. So this is the light shader. So there is no object file for the light. So only position we will set. One is 0, 0, 2. That is the position. Light specular, probably we don't need to set. Okay, light diffuse, this is important. So one is red color light. I believe only 4 we need to set. Shader I children append, and other we have another light. So we are talking about two lights. Okay, so if there is a surface, then one is red light and one is blue light. So two sides. So I believe it's clear. So mine z axis 2 and z axis -2. So two sides of the origin we are setting the light. 2 means it's a position light and not attenuated. So that is the idea. And light diffuse, we are one is red and one is blue. So this is red and this is blue. So two light we are setting. It's pretty easy code. Now I'll have a triangle. So triangle itself is a kind of object, shader object, obj file equal to triangle dot obj, that is available. Material diffuse. So for the unknown, okay, so for the unknown VAO that is there, so we'll set it to kind of 1. Okay, so I would show the triangle dot obj, and we can see that use material is none. So if use material is none, that is unknown. Triangle use material is unknown. Okay. Now triangle 2 in this object will add one more, that is a kind of stick. Shader obj file equal to stick.obj material diffuse equal to, so there is a stick okay, so this is material diffuse, and we'll set some transformation so that it would be at the center. So whatever the graphics we are showing, so this is like this only. Shader I dot children dot append triangle 2. That's it. So what we are doing is we are having two lights. Light position is set, diffuse color is set, and I have a triangle dot obj, so that is a model, and diffuse color is white. Okay, and I have in this object I have a children, that is a stick object, and again one color transformation minus 0.5 we have set in x-axis, and then we append. So shader I is global object and it has no object file, so it is a container of light and the model, and we append the triangle 2 in the shader I. So that is the concept. Now display, we don't need to change anything. Okay, so only we'll call our shader I display. So whenever something happens, shader I dot display and active equal to false. So this is the grammar. Okay, and then reshape, we don't need to do anything at all. We'll introduce keyboard function. So keyboard will kind of uncomment, and we'll say kind of diff keyboard. Okay, so we'll call glut post redisplay if shader dot keyboard 2. So this is the keyboard we are using. Key equal to key, x equal to x, and y equal to y, else none. Okay, so actually whatever the keyboard we are receiving, we are passing to keyboard 2, and if keyboard 2 returns true, means we need to flush it, redisplay. So otherwise we don't do anything. Done. So that is all. So this is the software that we have developed, and shader is a single file that has everything. So that is not all, it has many other functionality also. It's a small file. I believe shader is kind of 326 lines of code. That's it. And this 326 lines of code, then it does all the magic what we are seeing, and it would be doing many more magic. So that is the concept. Now we are instantiating the shader as with no object file. Two lights we are adding, and triangle we are adding. Inside the triangle we are adding one stick, and then we'll try. There is no harm in trying. Okay, so object file light position equal to light diffuse equal to. Okay, so initially the kind of Mr. Triangle is pointing in this direction, what we are saying. So it is flat. So we are going to rotate it. So okay, so there is error. Shader I is the instance. So we'll try again. Shader has no attribute record. Okay, so this is the way Mr. Software is. So I'll push something like shader I dot record equal to record. So we are doing recording. It identifies recording and playing. Type object shader has no attribute record. We set the attribute. Global shader I think we can do in better way. Okay, so I'll see the error again. Type object shader has no attribute record. Okay, so looks like this is a global parameter. So shader I none. Here only I can set shader dot record equal to record. I hope it should be all right. Better. Okay, so we will kind of rotate the triangle and we'll see. So we can see the triangle. Okay, so triangle. So this triangle is at this position, flat position, and it is rotating. So first it is facing the light, red light. So when it is facing the red light, it is illuminated as red. Now it is going opposite direction. Okay, so now it would face blue light. Okay. Stick is always red because it's a cylinder, and being a cylinder, it has normal in all direction and it is able to catch. So it's the back end is inside, it's a pipe. So back end is inside the cylinder. So everything what we see, this stick is outside. So outside means it is front side. So it is taking the light from the red light. So we have two lights as we discussed. One is a red light, that is front, and one is behind the scene, that is blue light. Okay, and when we are rotating, so now it is illuminated with the blue light. Now it is flat, the triangle is flat. Now it is getting illuminated with the red light, that we can see the stick. It is coming nearwards. Okay, so full illumination because of the red light. Okay, and now blue light is coming into the picture and illumination is happening because of the blue light. Okay, so probably kind of we can add some light source. I believe it should be look better to remove the confusion. So we can have a light source like the way we have. So we can add like shader I dot children dot append shader. Obj file is sphere.obj. A material diffuse color 1 will set at red. Material shininess equal to -1, and transformation equal to, will set it as -1, 0 and 2. So that is set already. I believe it is alright. And we will have another, and then it is blue. Okay, and we'll make it smaller. Look. Okay, so this software is like pretty easy to use. Okay, and it is at -2. We'll set this also some value, kind of x is this much, and z also will set like some -0.25. Okay, so it should, the stick should appear at the center. Okay, now sphere will add sphere.obj, and one is red and one is blue, and then transformation we are setting at, one is at same as the light position what we have set, and one is, so minus would be kind of 1. That's it. We'll copy shader, sphere.obj. We'll try. Okay, so it looks more promising. So we have two light sources, one is red and one is blue, and then we have the surface. So now I can rotate the surface the way we were doing. Okay, now red light is in effect. Okay, I believe stick should be at the center, so we'll try better next time. Okay, so the normal stick kind of resemble the normal, or I can change the color of the stick. -0.5, probably -1.5, and then color will, and I'll make it material okay, so I don't know, it will change the color depend upon the light. We have made light susceptible. Okay, so we'll make color as yellow of the stick, and material dot shininess equal to -1. So it won't change the color as per the light. It would be always yellow. Okay, now we'll rotate. Now it is peak. Now normal is down. Now normal would move towards the kind of blue light, and then it would display as blue. Okay, so now blue light is displaying, the normal is towards the blue light. So when we are rotating it, so what we are seeing, the blue, it is the back face. Okay, so now normal is perpendicular, now it is towards the red light, and we are seeing the red. This is front face. Normal is going towards blue light, and it is blue. What we are seeing is the back face. front face, back face. Full we can rotate if we want. It is front face, it is back face. Okay, so this is the analogy. Now as per the discussion what we discussed, now we will enable the cull face and we will cull the back side. So we'll say here GL enable GL cull face and GL cull face GL back side. Means this is what we are doing. So now we'll try. Okay, we'll rotate. So we can see the front face. Now normal is down. Still we are seeing it. Now normal is perpendicular down. Now if I rotate it, there is no color because back side we say don't display it. So even though normal is in the side of the blue light, but still we are not seeing anything. Now we are seeing red light. Okay, we can rotate complete stuff. Okay, now it is down. Now back side we don't want, even though it is getting displayed. So as per the discussion, it is not passing the test. Okay, even though it is coloring it as blue, but cull test it is failing. So in that sense, okay, so in that sense we won't get anything. Now front face we are getting. Okay, I don't know why this guy is going that far always. We have done transformation minus 0.5 y0. We'll try again even little less 0.05. Okay, and now idea is that we will do cull front. Okay, now we are doing cull front, this one. Okay, now when we are doing cull front, front side would not show. Now if I rotate now, front side is not getting showed. Now it is down the line. Now normal is going back side and it is, so back side it is eliminating and back side passing the cull test. So blue it is appearing, that the way we are seeing. But front side we are culling it. Nothing. I can rotate other way. Nothing. Front side we culled. Okay, this behavior we can kind of change it if we set the front as clockwise. By default it is anti-clockwise. So I'll set here. Okay, so before this GL front face is GL clockwise. Now the behavior would be opposite. Okay, when I cull front, okay, earlier when I was culling front it was showing blue color. Now I am culling front, it is showing front color because we did opposite way. Now the front is becoming back and back is becoming front because we changed the vertices rotation, so it is clockwise. So now what we are seeing the front, actually it is back. So in the code we are culling the front. So we culled the blue. So red it is showing the other way. Now back side there is nothing. it is showing red side. Okay, if I disable it, means by default it should cull the front, then it will show the front. Sorry, it will show the back, means we are culling the front. So it will show the blue. Okay, if I cull the back, then back would not appear. This is the default behavior, anti-clockwise. Only front is appearing, back is not appearing. Okay, now everything is same. I change the to clockwise. Now front would not appear. Means earlier we are seeing front red. Now red would not appear. It would only. So we change the kind of behavior opposite way. If we change its rotation type. Now if I set it GL cull face both sides, okay, everything gone. Okay, so I did cull front and back, so nothing is visible. I'll try. Gone, because we don't want anything. Okay, so not a good idea. So I'll kind of comment everything. Okay, and then I'll show the default behavior. And by default everything is alright. Front is red, back is blue, and now I'm going to change with default behavior. The front face is clockwise. Okay, so I believe it's alright. I changed the it's clockwise, so front is so whatever the front we are seeing now, so that is on the back side, and whatever the back we are seeing, that is in the front side. Okay, but the coloring is happening through the light source, so it doesn't matter. Okay, because both are enabled. Okay, so I'll show it again. Nice, going down. Okay, it appears bad if I do like this. I don't want front. If I don't want back. If I don't want now. Since both are opposite and only one will get drawn. Earlier both got drawn, so we saw the default behavior. But now one is missing, so I don't want back, and it is clockwise. Okay, so if I don't want back and it is anti-clockwise, then red would appear. Now blue would appear. Nothing. Okay, now blue would appear. Okay, so because only one is enabled. Now if I remove the culling of the face, then both would appear. Either it is clockwise or anti-clockwise. So nice. Okay, so we have covered every topic what we discussed.